Okay, in this example, we're going to look at a little different model. We're going to take a space module that weighs 15 metric tons on the surface of the Earth, and we need to figure out how much work is done by propelling it to a height of 800 miles above the Earth. So we're going to use 4,000 miles as the radius of the Earth, and we are not going to consider air resistance or the weight of the propellant in this case. So the first thing you'll notice, we're going to use this formula here. And the reason we're going to use that is that the amount of work here or the weight of an object involves the inverse square law. So the further you move it from the Earth, the lighter it gets, but it follows the inverse square law, whereas if you double the distance, then it weighs 1/4 as much. So the first thing that we're going to do is we're going to start out with this, and we're going to calculate C. Okay, so we know that on the surface of the Earth, this thing weighs 15 tons. And we know that the radius of the Earth is 4,000 miles, so that's going to be x. We're going to square that. Now we square the 4,000, and we should get 16 million. Yeah, 16 million. And then we're going to multiply both sides by 16 million, and we get C equals 240 million. So there's our constant. Now we're going to go in and we are going to find the amount of work. That's going to be the integral from 4,000 to 4,800. So that's going to be 240 million divided by x squared dx. So we can go ahead and pull the 240 million out. And just find the integral from 4,000 to 4,800 of 1 over x squared dx, which is also, you could write it as, let's just write it as x to the negative 2. Okay, so that's going to be 240 million times, let's see, that's going to be negative x to the negative 1 power, evaluated from 4,000 to 4,800. So pretty simple to do. We're going to just pull the negative out in front, and it's going to be negative 240 million divided by 4,800 minus negative 240 million divided by 4,000. And this comes out to be negative 50,000. And the minus and negative cancels out, and this ends up being 60,000, so plus 60,000. And that comes out to be a total of 10,000. And we've got to figure out our unit, and it's miles, so it's mile tons. We need 10,000 mile tons of force to get that thing lifted up 800 miles off the surface of the Earth.